Hi, good morning. In today's session, we're going to discuss about iceberg tables. How to use the Apache iceberg tables in Snowflake. Okay. In Snowflake Warehouse, they introduced this table called iceberg tables. It's one of the open table format designed for analytical workloads. Huge analytical workloads. If you have huge data, right, in your data lakes, if you take AWS data lakes, or it can be GCP, or it can be Azure, it can be any data lakes. If you have like petabytes of data, okay, you want to query those data from a file. Okay, for that, what we have to do is we have to create the iceberg tables. It's one of the Apache product. Okay, now this iceberg tables mostly used for huge analytical data sets. If you have terabytes of data, petabytes of data, then you have to go for iceberg tables. You can keep in your S3 bucket. You can build on data lake. Data lake is nothing but you can keep structured data, unstructured data, semi-structured data on a larger scale. Okay. If you are doing some data mining or kind of analytical things, you want to do some visualization, every data will take from the data lake. Okay. Data lake contains structured, semi-structured, unstructured data. Okay. Now, what happens, right? Though the data we're going to keep in a external storage. We're going to keep in a external storage. It can be any other cloud. It can be AWS or Azure or GCP. Okay, in the data lake, we are trying to get the data using iceberg tables. Now, in a distributed environment, if you want to maintain a large scale data, you want to query those large scale data, definitely you have to go for iceberg tables. This iceberg tables has various features. Okay, first one is I want to talk about the ACID transactions. This iceberg table supports what transactions, Sujita Priya? It supports ACID transactions. A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability. Now, I'm going to say what is in the atomicity, consistency, isolation, and durability. Okay. Now, this iceberg table supports ACID transaction. Everyone knows this ACID transaction. It's going to give you it's going to guarantee a reliable processing. Reliable processing means without error. It's a error-free processing you can able to do on database transactions. If you are doing some inserts or updates or delete, all is a transactions. In a banking terms, someone will credit money, they will withdraw the money. Okay, all things will happen. Each action is called a transaction. Sendamal, if someone is crediting money, it's one transaction. If someone is withdrawing the money, it's one kind of transaction. Okay, both will happen the concurrent way. Okay, if one is depositing to the other account, what happens? That account should be credited. From your account, withdraw should happen. Okay, the simultaneous concurrent action should happen. Okay, now this ACID transactions, it's going to give you a guarantee, is not going to guarantee the reliable processing of database transactions. Error-free transactions is going to happen, and then you can able to maintain the data integrity as well. Okay, data integrity is nothing but if you are depositing the money, credit should happen to that account. Withdraw should happen to your account. Okay, that is nothing but data integrity maintained between the two accounts. Okay, that's what I'm saying. Data integrity is maintained, as well as even in case of any errors happen during transactions or power failures. Suddenly some power failure happens while doing some transaction, power failure happens. Okay, or other issues, any kind of issues. Okay, some kind of disaster issues or any kind of issues. Okay, but this database transaction should have maintain a data integrity. Even in case of power failures, even in case of errors, should happen. Now, Sendamal going to ATM. is going to withdraw 10,000 rupees. Suddenly some powerful happens. What happens? Anyhow, whatever is withdrawing the amount, right? That amount should be, okay, enter into the database transaction. He entered the amount and then is trying the enter button. Okay, what happens, right? And at the same time, the transactions will be committed in the database. Okay, that's what I'm saying. You have to maintain the data integrity. The first one I'm going to talk about is atomicity. Okay, the atomicity is nothing but each transactions you are doing, right, all will be treated as single transactions. So, if I talk about atomicity, atomicity is nothing but each transaction you are doing in the bank, right, all will be treated as single transaction. Okay. If you are doing some transactions or complete successfully or none of them, okay, if not successfully completed, not complete successful transaction, each transaction will be treated as single transaction, or we can say is indivisible unit. Indivisible unit means single transactions. Okay, now I'll give one real-time example. Okay, now Sujita Priya is there. Okay, she's going to transfer the 10,000 rupees to another account. 10,000 rupees to another account from HDFC to Karur Vysya Bank. Okay, now what happens, right? That in atomicity, what happens if she deposit 10,000 to some other account? What will happen? Debiting will happen in one account, crediting will happen in another account. Okay. Now, if any of the crediting or debiting fails, the entire transaction will be rolled back. So, got it? Atom is nothing but what are the transactions you're doing, right? All are single units, single transactions or indivisible units. Now, Sujita Priya, what is doing, right? She's depositing 10,000 rupees to some other account. What happens? Some, I can say some operation got failed while crediting, or it can be debiting. Any one of the transaction got failed. Now, what will happen? The entire transaction will be rolled back. Rolled back means I have 1 lakh, Sujita is having 1 lakh amount. She's crediting 10,000 rupees to some other account. While crediting, due to some bank server issues, it's got failed. What will happen? She will get the same 1 lakh amount. Got it? Guys, very simple, guys. Very simple. Now, Sujita Priya is having around 1 lakh. Okay, now she is crediting to some other account 10,000 rupees. 10,000 rupees. Now, what happens? While doing transactions, okay, some server issues, it's got failed. Now, what happens? The entire transaction will be rolled back. Okay. Now, Sujita is paying to Anand. Sujita is paying to Anand. Anand already have the amount of 20,000 rupees. 20,000 rupees. If we, Sujita is crediting 10,000 rupees, what's the Anand total amount will be? Sujita is having 1 lakh rupees. She is crediting 10,000 rupees to Anand. Now, Anand, what amount he'll have finally? 30,000 rupees he will have. Okay. While doing Sujita transaction, it's got failed. Now, entire transaction got rolled back. Now, what will be the Anand will have amount? What I can say, like what amount Anand will have? Sujita Priya?
20,000, sir.
20,000. Sujita Priya?
1 lakh.
1 lakh. 1 lakh. Try to come in English, guys. Sujita will have the 1 lakh amount. That's what I'm saying. The entire transaction will get rolled back if any of the transaction got failed. Because I said automation is nothing but single unit. It's a single transactions. Okay, all are independent single transactions. That's what automation is nothing but. Now everything is clear, right? If you talk about atomicity, you can directly say to them, Atomicity is nothing but your treated as a single or indivisible unit. Okay. Now we will talk about the consistency. C stands for consistency. Okay. Now, if you are doing some transactions, okay, any deposit or withdraw, anything you are doing some transactions in your bank account, what happens when you are doing some transactions? Each transaction move from one valid state to another valid state. One valid state to another valid state. Okay, what happens, right? I'm paying 10,000 rupees to Anand. Okay, what will happen, right? From my account, the withdrawal will happen. That's one state. After that, the 10,000 will be deposited to Anand. Okay, it will be credited. Okay, this change will be changed. That is nothing but a consistency from one valid state to another valid state. We can maintain the data integrity of the data according to the predefined rules. Now, already defined some predefined rules in the bank accounts. If someone is crediting the amount from his account, the amount has to withdraw. And then another account, the amount should get deposited. This is how they define some, they have defined some predefined rules. That is nothing but we are maintaining the data. We are maintaining data. What's the concept name? We are maintaining data integrity. We are maintaining data integrity. Okay, all data is nothing but we are defining some predefined rules that might be include table constraints as well as cascade. You have used cascade, right, in table level. If you if you delete one record from the table, automatically which table having the foreign key relationship, that foreign key relationship record will get null. I have two tables having the foreign key relationship. Okay, if I deleted one row from the table, automatically in the remaining table, it will reflect as a null value. That's what I'm saying is we are maintaining the data integrity. Okay, like using cascades or triggers. Okay, now in banking terms, I'll give example for consistency. Now, I'll give an example. The total amount of money across all accounts remains same before and after a transaction. Sridhar, got it? The total amount of money across all accounts remains same before and after transactions. Anand will have 20,000. I have 50,000. Some other people will have 1 lakh. Okay, we have different money across all accounts. Okay, now what happens, right? If someone, guys, make it mute. If a transaction is performed, what will happen, right? The total balance should reflect the change accurately. That's why it's called data integrity. Guys, don't get confused. Automatically, what will happen, right? All will treat a single unit. If one transaction got failed, everything will get rolled back. This is nothing but all bank accounts will have the some money, okay, before and after transaction. If a transfer operation is performed, the total balance should reflect this change accurately. If I'm depositing 10,000 rupees, withdrawal should happen 10,000 for me, credit should happen 10,000 for Anand. This is how it works. That's why we are maintaining the data integrity. If anything happened in my account, suddenly in some other account, some changes should get reflect in my account as well as some other account. The reflection should will happen. Okay, good. That is nothing but consistency. Now, on anybody can say what is atomicity? All transactions will be treated single transactions. If one transaction got failed, the entire transaction got rolled back. What is the consistency? We have to maintain data integrity between the two bank accounts. If one of the, so how to say in the sense, if I'm crediting some money to the other account, automatically that that should reflect the change accurately. Okay, that is nothing but consistency. Third one is nothing but isolation. Okay, isolation nothing but name itself. We have the answer. Isolation, separate. The transactions are executed in isolation from one another. Isolation from one another. It is separate from one another transaction. Okay. Now I'm paying 20,000 rupees to some Anand. Okay. From my account, withdraw will happen. That withdraw things Anand never know. How to say? Whatever money is withdrawing from my account, Anand does not know the information. Whatever money I sent, right? That money only I know. How much amount Anand is holding, that I don't know. Okay, that's what I'm saying is isolation, nothing but okay, each transaction is isolated. Okay, the transactions are invisible to another transactions. Okay, we can't able to see the entire amount from Anand. Okay, what are the amount I'm sending to Anand, that amount only I know. Okay, what are the Anand having the total amount, right? I don't know. Okay, that's what we can able to see only the partial results. Now I'll give example for isolation. Okay, suppose two transactions are there, are trying to update the same account balance simultaneously. Now, one transaction is completed, then only the other transaction will start. Okay, first what will happen? If I pay 10,000 rupees, first withdrawal will happen for me, and then only credit will happen to Anand account. That's why the transactions are very isolated. Okay, even though I'm initiating the transaction, what happens, right? It will withdraw and then will credit for Anand. That's how it works. Now, you might have a question. If Anand also initiating the payment for me, I am also initiating payment for Anand, what will happen? That's why its isolation comes in. Okay, it will be a separate transaction. Once the transaction is completed, then only other transaction comes in. Okay, in order to prevent the data corruption or inconsistencies, we are using isolation. Now, the last one is durability. Okay, durability. Durability is nothing but, like, for example, I'm doing some transactions. While doing some transaction, some system failure or power failure or system got crashed, my ATM got crashed, okay, deposit machine got crashed, anything can happen. Okay, even though my system got crashed or power failure happens, what are the transaction I'm doing, right? That should be permanently recorded in the database. That is nothing but durability. Someone got it right? I'm doing some transactions. I'm depositing in my money in the machine. Okay, now I'm depositing a 1 lakh money. While depositing, what happens, right? Just I'm paying 1 lakh. At the time, some power failures or system crash happen. What happens? What are the changes you did, right? All the transactions are permanently recorded in the database. Okay, I can give one example for this. Now, I'm just what I'm doing is same example. I'm paying around 5 lakhs to somebody. Okay, what happens? Suddenly my transactions completes. Okay, system got crashed. Even system got crashed, my transaction get complete. And then the transaction will get complete. Okay, this is how it happens. It's called durability. Now, next one, I'm going to talk about the schema evaluation, hidden partitioning, and table snapshots. Before going to the schema evaluation, I will say iceberg tables predominantly used in data lakes. Okay, in order to improve the query performance, they will go for the iceberg tables. Mostly iceberg tables will use in Snowflake. In order to increase the query performance and query semantics of your regular Snowflake tables. All the datas and metadatas will be stored in the external cloud storage. It can be AWS or Azure, or it can be GCP. Okay. Now, this data will be stored in the file format called Apache Parquet, because Apache Parquet is one of the columnar storage. We can able to read the data very faster. So that's the reason they are storing the data in which format?
Apache Parquet.
Apache Parquet file format. It's one of the columnar storage. Okay. Now we'll see. Okay, we'll see the things one by one. What is nothing but schema evaluation. Okay. Now in today I have 5 columns. Tomorrow I'm going to have 8 more columns in my data, and then a third day I'm going to have 12 columns. Okay, this is how what will happen. My schemas keep on changing. Okay, not keep on changing. Some like 6 months it keep on changing. Okay, what happens, right? Even though the schema got changed, it won't compromise the query performance. It won't compromise the query performance. The query performance will be very faster. Schema is nothing but the schema going to change, like it can be after 3 months or it can be 1 week. I don't know. Okay, the columns going to change. Now what happens, even though my schema got changed, right, it can be able to read the data very faster. Now you may have a question. Yeah, I have 10 columns. Tomorrow I have 8 columns. Because though you are storing the data in a column storage, what happens if one of column is reduced or one of column is increased in the data? What happens? You might have a question like whether it's going to impact my query performance while reading the data. No, because it has the schema evaluation property. As per the schema changes, automatically we're going to increase the columns in the Parquet file as well. That's why it's called schema evaluation. Okay, it won't compromise the query performance. And then I'll talk about the hidden partition later. Okay, because no need to partition your iceberg tables. Internally, what will happen, right? It will partition the data as per the workloads, data workloads we are using, right? Dynamic partition is there. Automatically, it will choose which column I asked to partition. It will choose automatically columns and then we'll do the partitioning. Okay, all kind of stuffs will be available in the iceberg tables. Now we'll little bit go inside. Now we'll talk about the data storage part in iceberg tables. I already said, where are you going to keep the data? In Snowflake or external storage?
External storage, sir.
Yeah, we're going to keep the data in the external storage. It can be a S3 or Azure storage or GCS. Now, the external storage is not part of Snowflake. Okay, all managements of external cloud storage locations, data protection and recovery. Okay, everything taken care by the everything taken care by the Snowflake. Okay, only which one? Management and then configuration, data protection and recovery. Okay, Snowflake does not support failsafe for iceberg tables. Guys, I'm saying to you again, iceberg tables, Snowflake does not support any failsafe storage for iceberg tables. Okay, that's what you have to keep in mind. Now, one more thing you have to keep in mind while working in the iceberg tables called external volume. External volume. Now, whenever you want to connect your external storage, you'll use storage integration, right? You'll use storage integration. Guys, I already took some external tables. Okay, external tables as well as Snowpipe. What will you use? To connect the external storage location, what will you use? Storage integration. Create or replace. Sujita Priya, create or replace?
Storage integration.
For iceberg tables, we should use, what you should use? You should use the external volume. This is the one we have to use for connecting to your external storage. Now, this external volume, okay, is one of the named account, Snowflake object, account level Snowflake object. Now, if you want to connect your external cloud storage for iceberg tables, then you have to go with your external volume. This external volume, what will happen, right? It will store all the IAM information, identity access management. It will be provided by AWS, okay, for your storage locations where the data got stored, okay. And then how to access those data, we need some credentials, okay. All credential informations will be available in this IAM. And then if you want to connect to the cloud storage, then you need external
Volume, sir.
volume, okay. And then I already said, right, Snowflake use IAM identity to securely connect your storage for accessing the table data, okay. What we have to do, right, Snowflake uses IAM to securely connect your storage for accessing the table data. And then I already said for each file we have the metadata, okay, how many records, what the schema, every information will be stored in the metadata. This metadata also will be stored in the external storage location, and manifest files will be also be there, okay. What the table schema, what is the partitions, other metadata, all things will be available in the manifest file as well, okay. How many partitions it took, or what is the other metadata, all kind of informations will be stored in this external storage. In order to get that table data, what we have to use? What do you have to use?
External volume.
External volume. Okay, if you are using Snowpipe, in order to access data, what will you use? If you are using Snowpipe.
Storage integration.
Storage integration you have to use. Already we have discussed so many things. Okay, now this external volume can support one or more Iceberg tables. One Snowpipe, what we'll do, right? We'll create one storage integration for one Snowpipe. Okay, one storage integration for one Snowpipe. You can use multiple storage integration for Snowpipe as well. The same thing here also there follows. One volume will support one or more Iceberg tables. One or more Iceberg tables. Now I'm going to discuss about the Iceberg catalog. Okay. Now you guys are new to this Iceberg catalog, right? Okay. Now before going to this Iceberg catalog, I want to discuss few things about data lake. About data lake, where you use this data lake, okay, everything you want to see. Data lake is nothing but centralized repository. You can store your structured data, unstructured data, semi-structured data, and then APIs data, okay, IoT data, all kind of sensor data you can keep in the data lake. Okay, you can have flat files, structured file formats, unstructured audio, video, semi-structured JSON, XMLs, or API data, or IoT data, okay, or any kind of sensor data also you can keep in the data lake. And then for mostly they use data lakes for analytical purpose, okay, for dashboards, to visualize some data using Power BI or Tableau, or if you want to do some machine learning models, they will use data from the data lake. Okay, the important features in data lake is scalability. Scalability means you can put large volume of data. You can put large volume of data. Yeah, you can put large volume of data. Okay, that's why it's called scalability. You can put terabytes of data, petabytes of data. Okay, anything you can do. And then a second one is we have diverse data types. You can store semi-structured, structured, unstructured. Okay, all kind of diverse data types you can keep in the data lakes. And then third thing I can say is schema on read. Schema on read means you can have a predefined schema. Okay, you have some predefined schema means you can give some columns and you can be able to extract the data. That's called schema on read. You can define your schema. Based on schema, you can able to read the data from the files. And then last one I can say is cost-effective storage, because the data lakes mostly offer the low-cost storage options. Okay, very cost-effective for storing the vast amount of data. If you want to store petabytes of data, then you can go for data lakes. And then last feature I can say is for advanced analytics. If you want to do some machine learning, predictive modeling, or data mining, or kind of some advanced analytics, you can go for the data lakes. And then mostly the data lakes, what will they will do is data ingestion they will do. Okay, the data will come to the data lake in terms of any ETL tools, like we can use Talend or Ab Initio or Pentaho. Okay, using the ETL tool, you can able to ingest data into the data lake, or it can be come from any real-time streams, or it can come from multiple sources. Okay, multiple files that might become. Okay, and then we can use some common ingestion tools, Talend, Ab Initio, Informatica Power Center, or Informatica IACS, or Apache Kafka, Apache Flume, and AWS Kinesis. Okay, in this way you can able to ingest the data into the data lake. Second one I'm going to talk about is data storage. You can store the data in data lake in raw format. Raw format in the sense, okay, you can store audios, videos, any kind of data you can store in the data lakes. Okay, now it can be S3, or it can be a blob storage, or it can be a GCS. Any cloud storage you can be able to create data lakes. And then in data lakes, they'll use various data processing frameworks like Apache Spark, Apache Flink, and AWS Lambda to process data. Whatever the data you stored in data lake, right? You can able to process data using these processing tools, Flink, Spark, and latest Lambda. You can able to process data from the data lake, and then you can do all kind of transformations. And then next thing is we'll talk about data governance. In data governance, whatever the data you kept in the data lake, you have to ensure the data quality. How the data quality is, whether the data is having null records, okay, whether they are having any duplicates, all kind of data quality checks you can ensure it, and then you can confirm a security, okay, and then any compliance is there or not, okay, all things we can all governance things we can able to do. And then using data governance, we can use Apache Atlas, AWS Lake Formation, and Azure Data Catalog. You can able to manage and govern all those data. And then if you want to do some data consumption from data lake, what we can do is you can use machine learning models, as well as you can use some visualization tools like Power BI, Tableaus. Okay, and then you can use SQL queries as well to read the data. Okay, all things we can do by using iceberg tables. You can able to, after creating iceberg tables, you can able to query the data from the lakes. And then you might have a question like, what are the use cases for the data lakes? Okay, if you want to handle large amount of volume of data for analytic purpose, then you can go for data lakes. If you want to handle large amount of data for analytic purpose, you can go for data lakes. And then if you want to process large data sets for training machine learning models, you can use data lakes. And then if you want to do the archiving, long-term archiving, okay, like 50 years of data I want to archive, 25 years of data I want to archive, then you can go for data lakes for data archiving purpose. And then data integration also, you can go for data lakes. You can able to combine all the disparate source of data and then put in a data lake. For that purpose, you can go for data lakes. Okay. See, the only major difference between the data warehouse and data lake is, in data warehouse, you will store your predefined schemas. Okay. In data lakes, you can store raw data. There's no kind of any predefined schema in data lakes. You can store any kind of data. But in data warehouse, you have to keep only predefined schemas. And then in data warehouse, you can able to handle only structured data. Okay. But in data lakes, you can keep structured data, semi-structured, unstructured you can keep, and then can run some complex analytic workload as well in data lakes. And then cost-wise, okay, data lakes, it's one of the cost-effective one when compared to the data warehouse. Okay, when come to the flexibility part, data lakes offers more flexibility, and we can do all kind of analysis we can do. And then what are challenges we have in data lake in the sense? We can have the high quality data lakes because we are using implementing some data governance. We have the data governance team will say how to improve data quality. Okay, and then you can manage the data security, privacy, and compliance in data lakes. And then query performance can be slower. That's the only drawback I can see in data lakes. Query performance will be slower when compared to data warehouse because though it's not right, it will take so much of time to read. That's the only drawback I can see. Guys, these are the various advantages of data lakes. Mostly, if you are trying to create some iceberg tables on top of the data lakes only, you can able to create the iceberg tables. Now, everything done right. Asset transactions, schema evolutions, and now we'll talk about the hidden partitioning. Now, hidden partitioning. See, in iceberg tables, hidden partitioning feature is available. Okay, user no need to worry about how to manage the partition columns. Everything taken care by the iceberg itself. Iceberg contains automatic partitioning. Automatic partitioning means what happens, right? Based on the data characteristics, it will create the partitions. User no need to explicitly define partition columns. Okay. Now, because of this feature, automatic partitioning, right? It's going to reduce the complexity and potential errors. No need to choose a column for partitioning. Everything taken care by automatic partition taken care by iceberg tables, automatic partition. No need to define any columns. Everything taken by the iceberg itself. Now, because of hidden partitioning, one more advantage also we have that is called improved query performance. Because it's automatically determining the best partition strategy. Iceberg will have one layout, okay? Based on the data layout, it will choose a corresponding column as a partition column that might give you a faster query performance. As well as because of faster query performance, you can see very faster query execution times, especially for the larger data sets. What they're saying is, we have your strategy. Iceberg will have strategy, okay? Based on the data layout, it will choose a corresponding column. Which column is suitable for partitioning? It will choose automatically. Because of that, it's giving the good query performance. Now, the third feature hidden partitioning is simplified schema evolution. Okay, I already discussed the schema evolution, but anyhow, I will make some important points in the hidden partitioning. It's one of the feature. Hidden partitioning and schema evolution, right? Schema changes will be very easier. User no need to worry about the updating partition columns manually because the schemas keep on changing means automatically as per the data layout, it's going to choose a corresponding column. Today, I have 5 columns. In that 5 columns, it choose to one column as partition column. Tomorrow, I have only 4 columns. Whatever the iceberg table has choose a partition column, right? That column is not available today. What we'll do, based on the 4 columns, it will choose one column partition column, and then it will give the good query performance. That's why I'm saying schema evolution. Schema evolution means schema will be keep on. Schema will be keep on changing. Schema is nothing but schema will keep on changing. Okay, that's what the iceberg table is saying, that if your schemas keep on changing, what are the column it choose the previous partition column? The column is not available next day. It will choose what are the columns it has, right? From the available columns, it will choose the partition column. Okay, user no need to worry about it. And then this hidden partitioning having one more feature called partition pruning. Okay, partition pruning is nothing but only relevant partitions are scanned. For example, city called Chennai, city called Hyderabad. City is a partition column. City is a partition column. City called Chennai, city called Hyderabad, city called Delhi. Now, if I putting where city called Chennai, only that particular partition will be scanned. The remaining all partition columns will be pruned. That is nothing but partition pruning. In iceberg tables, if you try to query some data, it will go and scan only the corresponding partition. The remaining partitions will be pruned. Okay, because of that, it's giving the good query performance, good read as well as improving performance in iceberg tables because it contains partition pruning. Sujita, do you know what is partition pruning? Only relevant partition will be scanned. The remaining partition will be skipped. If you use where query, where city equal Chennai, only city equal Chennai will be scanned. Partition will be scanned. The remaining partition won't be scanned. That's why we can able to improve the read performance as well as we can improve the performance of the data. Yeah, now this is nothing but hidden partitioning. Okay, now last part I'm going to discuss about table snapshots, guys. Okay, table snapshots. Just will come down here. Yeah, iceberg tables use a snapshot based querying model. What we'll do, right? Today, 2 files came into the AWS cloud storage. Now what happens? I'm creating iceberg tables for that 2 files. The 2 files kind of same schema. Okay, for 2 files I'm creating one iceberg tables. Each file will have 100 records. 2 files will have how many records? Each file will have 100 records. The 2 files will have how many records? Each file will have 100 records. Now, 200 records will be there. For 200 records, I'm creating an iceberg table. Now, tomorrow, 5 files coming. Each file contains 100 records. Now, your iceberg table contains how many records now? Yesterday, 200 records are there. Today, 5 files comes in. Each file contains 100 records. Now, total records in iceberg table is
700, sir.
700 records. What this iceberg table will do, right? It will create a snapshot. Snapshot means yesterday 2 files came. For 2 files, it will do the mapping. 2 files, it will do the mapping, and then it will take a snapshot. Snapshot is nothing but a backup. Okay, and then tomorrow 5 files going to come. What will happen, right? It will take again one snapshot. Now, if you want to see the previous version, you can see in the iceberg tables. If you want to see previous version means only 2 files will be there. I can able to see 200 records. If you want to see the latest version, I can able to see it contains 700 records. Okay, this is how I can able to have a snapshot. This iceberg table, we internally will do all these things. No need to do anything. Okay, it's going to map the data files using manifest and meta files. Okay, whenever the new file comes in, right, all kind of informations will be stored in the metadata. Okay, how many records came, how many files came, all kind of informations will be stored in
Metadata.
And manifest files as well. Okay, that's what it's saying. It's like a null scheme. Okay, all kind of informations, as well as it will do the snapshotting as well. Okay, whenever the new files comes in, right, we'll take a snapshot. Whenever the new files comes in, we'll take another snapshot. Okay, it will have all snapshots. If any failure happens, if you want to go to the previous version, you can able to query it. That's the use of snapshots. Guys, this is the basic things about the iceberg tables. In tomorrow's session, we're going to see about the cataloging of the iceberg tables, as well as we're going to see the implementation of iceberg tables in two ways. One is Snowflake catalog, another one is AWS Glue catalog. We're going to see two different catalogs. We're going to see tomorrow. Okay, I am going to close session right now.